Hey everyone, I hope that you're all good. So let me share my screen. So when I usually present Touca, I go basically show code and then walk you through how we can actually use Touca in action. Now I want to make a little kind of change here because we are going to do on some programming and use the Touca SDK. I want to make it a little different just to give you an idea of what Touca is and then let all of us together kind of explore how to use it in action. Don't worry, I still show some code to give that understanding first. What you see here on my screen is the Touca server interface. It's a web app deployed right now to app.touca.io, but it can also be deployed locally. It doesn't have to be on the cloud. The idea behind Touca is that when you have a large code base and you're making code changes to it, you want to make sure that you're making the code changes that are safe, that you understand their side effects, and that you are not causing regressions as you are making changes. So the cost to finding these changes or side effects grows substantially with time. So if I make a code change now, and then I immediately get feedback that hey, I'm breaking this test case, or this corner case, I'm not handling it very well, then it's easy for me to go make fixes because I have the context. It's the exact, like I have everything in my mind to go fix that. But if then I have to wait for a QA engineering team to come and fix that, then of course it would be more costly. So let alone, if we are finding regressions after deployment, that would be much more expensive for us to fix. Because again, we might have moved on. We don't have the context. We don't have that mental state to actually understand how this would have happened in real world. So perhaps the best way to give you a story is to just tell you how I started Touca. I was working at this company. In fact, I can give you this picture just to give you an idea of what we are dealing with. Let me. Okay, I found. Yeah. So I just want to share this picture. So this is the type of software that I was building. This is basically a visualization of an MRI or CT scan, in this case, a CT scan that you see here. CT scan data sets are 2D images, but when we want to basically build this image that you saw, we want to kind of create this 3D object model out of those 2D images. So there's a 6 million line of code software for that, and I was part of a team that was assigned to actually refactor one of the low-level components of the software. That was 500,000 lines of code. So of course, we all thought that it would take 6 months, but then it took 2 years. And the reason it took that long because we underestimated the time that it takes for us to make sure we're not breaking our software as we are delivering these changes. Because our policy dictated that every time we make a code change, we had to wait for our QA test team to come and make, basically make sure that we are not breaking our software. So I started Touca basically to make us, the developers, kind of self-sufficient in that at least we can have a first pass of our changes automatically as we are making code changes, and then basically our QA team can go do the deeper testing that is needed. But that made a huge impact. So I basically continued working on this, and after a good basically 2 years, I finally got the IP rights, and then I started this kind of basically changing Touca from an internal tool to a product. All right, I'm sorry for a long intro here. Now I think you still need basically some understanding of how this works. Let's just start with the very basic thing. So let's just say we want to test an is prime function. The way that we can do it is to write a unit test. You can say, hey, we have these inputs. I want to pass these inputs to my, is prime function, and then check, if I am correctly handling these inputs. That the output of this function matches my expectation. Now, this assert false and assert true in a way are basically explicitly hard coding our expectations. Now, if you have, say, 1 million of these numbers or test cases in this case, it would be difficult if you want to make sure that you are, doing the right, basically using the right expected values. And if you're making code changes repeatedly to our software, chances are we might want to at some point change the expected behavior of our software. So sometimes we have to go back and make adjustments to our unit test, which can be costly again if you have too many test cases. So an alternative to unit testing, even though there's nothing against unit testing is very effective, but sometimes a better way for handling these large inputs and making sure that our software can handle them correctly is to kind of create an acceptance test or regression test where we just say, here's how our software works today. Let's just agree that this is the trusted version of our software. So let's just make sure that our future changes are not going to make it worse or make it any different. Or if they are making it different, let's just check it. There are a ton of acceptance tools already in the market, but what distinguishes Touca a little bit is that you don't basically need to basically merge or explain your software behavior by basically generating an output and storing it in a file. So the idea here is that you can basically capture the behavior and performance of your software by simply just tracking values of variables and runtime of functions. And then as you are basically making these changes, then we will run that same workflow, basically capture the same variables again, and then compare your description against the previous description. Now, however, we don't store them in a file. We submit them to basically this web app that I showed you earlier. So let's just imagine in this case that I have a profile database with 5 different versions already submitted. Now, the idea is if I have Touca integrated with my CI, as I'm making changes, as I push to my branch, I can build that code, run the test, and then generate this kind of description of my behavior and performance and submit it to this result as, say, version 6. So in this case, let's just say we just submitted version 5. If I click on it, then I see how version 5 is behaving in comparison with the trusted version of my software, which is version 2. So in this case, let's just say this profile database is, basically taking a username and then providing the basic information about each student. So now, if you have 3 students as test cases, then we can see, if the output or basically the output student information for these test cases are matching the output that was in version 2. So in this case, there are differences. So I can click on it and see what variables are different here. Now, so let's now focus on the code side to generate this basically Touca test or Touca workflow. We would need to create this kind of test application. Of course, we can kind of mount this on the JUnit platform in Java, but the code that you see here is a standalone Java application. It has a main function that takes basically that simply runs the Touca test framework. And the Touca test framework has a kind of a standalone command line interface that you can interact with. But the idea is it just basically runs any function in this class that has a Touca workflow annotation. So in this case, I'm saying, when I am running this test, call this isPrime function with the test cases that I am going to provide to you. And then every time that I have a test case, then I'm going to call this isPrime function with the appropriate number corresponding to that test case. And then whatever its output is, I'm just going to accept that as the actual value for in this version, and then submit that, serialize that in binary, and then submit that to the Touca server, where all the comparison against the baseline and everything else happens remotely and automatically. So all we need to do is to just basically describe what we want to happen for these test cases that we are providing as a parameter. And this is a parameter because this has its own command line interface, then we can pass these test cases from the command line externally, so that if you have 100 or thousands of test cases, we don't need to repeat ourselves and have different functions here, or write more code. In fact, if we have submitted a bunch of test cases for a given version, chances are we want to test our workflow with the same set of test cases. So in that case, because we are communicating with a cloud platform, separate compute resource, we can query that list and therefore not even need to pass the set of test cases anymore for future versions of our code. So in this case, what happens is if I am calling this isPrime function with a given number, then I am going to take the expected value and then associate it with this name and then submit it to this platform. So let's do that. This is the only kind of minimal example that I want to run myself to just give you, kind of overview of how it works. And then we can just wrap this up and then just show, basically work together to go basically build more useful, use more useful examples. So in this case, I'm going to test that isPrime function. So therefore, I'm going to create a suite called isPrime. And here you see that when I created the suite, now the server is giving me an API key and an API URL. I'm going to export these as environment variables. So therefore, every time that I'm running a tool, the Touca test framework can find these parameters. Now, what I will do is to just basically, because this is a Gradle kind of app, I'm going to just run the example minimal, which is a kind of task here, a Gradle task that runs this, this application that I was showing you. And then I'm going to basically pass a bunch of command line arguments to my application. So in this case, I'm saying I want to name the very first version of my my code, code under test, in this case, my isPrime function, as version 1. And I am going to pass a bunch of test cases to it. So I'm passing them from the command line here, but I can pass a file instead and then have the test framework actually parse the file and use every line as test cases. So in this case, let's just say we want to see how our code behaves for these three test cases. Now, if I run this example, then Gradle is going to basically run this standalone app and then pass the command line arguments to the test framework. And then if I go back to the test, the web app, you see that version 1 is submitted here. Now, the idea here is now if I go and make changes to my isPrime function, then all I need to do is to just basically push that code to some branch, and then have my CI actually run the same command that I ran here on the command line, so that it basically posts a new version of my code, runs the same the same workflow with the same set of test cases. Now, if it basically produces a different result, then of course we would need to go inspect that and see if there are differences. So here you see that all the three test cases that I submitted are here. I can click on these, any one of these, to see the actual value in this version 1 of my test. Okay, so that's all. I think all that remains is for me to just show you what's, what happens once there are differences. So when there are differences, as I said, the platform, the Touca server is automatically going to compare the results, create a report, and then if you are subscribed to a given suite, it would just send you an email. But in this case, let's just say that we received that email, we inspected the test results and determined that, in fact, this is not a regression, that we intentionally wanted to change the behavior of this test case. In that case, then I can go ahead and then basically promote this new version 5 of my code as the baseline version. I can even provide a comment to let my teammates know why I'm doing this. But when I am basically promoting this, then if I go back to my profile database, version 5 is considered the baseline, so that my future versions of my code would be automatically compared against version 5 from now on. So therefore, there's always this baseline that you can maintain of how you expect your software to behave. And then you basically check the actual behavior of software continuously against that baseline. And that's pretty much it. I think I made a lot of twist to my actual usual demo, because I'm looking forward to actually run the more kind of interesting examples with you together in on some programming session. Thank you.